Welcome back to the deep dive. Tonight, something pretty spectacular is happening up there, a celestial event that's, well, it's really captured people's imaginations for, gosh, millennia. We are talking about the Blood Moon 2025.
Yeah.
Okay, so let's unpack this a bit. Our mission today, a proper deep dive into this phenomenon. We want to explore exactly what a blood moon is, the science, the really fascinating science behind that dramatic red color, and, crucially, where you might be able to see it tonight and sort of why it has that really captivating, almost mythic name.
Yeah.
We're drawing on some great sources, including one called Blood Moon 2025, a celestial spectacle. Got some really good stuff from that.
Yeah, and what's so interesting, I think, is how it perfectly blends that sort of ancient awe, with our modern understanding. It's more than just looking at something beautiful. It connects us to how people throughout history have seen these things. The source points out how these sites could be genuinely unsettling, awe-inspiring, long before we knew the physics, and we'll bridge that, explore the history and the science behind it all.
Absolutely. And it's amazing how sometimes the science actually makes it more wondrous, doesn't it? Not less.
Yeah.
So, okay, the core definition. What actually is a blood moon?
Well, fundamentally, it's a total lunar eclipse.
Right.
Simple as that.
Right.
Sun, Earth, Moon, they line up just right, perfectly. And Earth's shadow falls directly onto the Moon's surface.
But the blood moon part isn't just the shadow, it's that color, right? That striking, deep red glow the moon takes on. It really is unforgettable if you get a chance to see it properly.
Yeah.
But let's maybe rewind a bit. Think about seeing that centuries ago. No explanation. That crimson moon. What must that have felt like? The article mentions how this rare sight fascinated and even unsettled humankind for centuries. Just imagine that. For us, maybe it's a cool photo, right? An excuse to stay up late.
Yeah.
But back then, seeing the moon, usually bright white or silver, suddenly turned this deep, almost blood-like red.
Well, yeah. That's powerful. Potentially terrifying, even. Oh, definitely. That unsettled part is key. Think about it in the grand scheme of things. Seeing the sky change so dramatically without knowing why. Before we had astrophysics, before we understood orbits and light, people made sense of it differently.
Through myths and stories.
Exactly. Through their own cultural lenses, often filled with meaning, sometimes predicting doom, sometimes something divine. Our source actually mentions some examples, like in ancient Mesopotamia, some saw it as a direct threat to the king.
Wow.
Yeah, they even had rituals, sometimes a substitute king, just to deflect the perceived danger.
That's incredible.
And other cultures, Incas, some Native American groups, they had myths about giant jaguars or dragons attacking the moon, making it bleed.
Yeah.
It wasn't just a weird sight. It shaped how they saw the world, their spirituality, their society. It shows how linked astronomy and culture were.
Which really highlights the journey to our current understanding, doesn't it? From fear to fascination, maybe.
Precisely. It shows how far we've come in understanding the cosmos.
Yeah, that's a great point. The sky was once this canvas for prophecy, and now we understand the physics behind the paint strokes, so to speak. Which brings us neatly to the big question everyone asks. Why red? Why does the moon turn red during a total lunar eclipse? It feels almost magical, but what you're saying is pure physics. And astrophysicist Ryan Milligan from Queen's University Belfast explains it really well.
He does. Milligan's explanation is super clear, and it demystifies it without losing the wonder, which I like. He says the redness happens because of how Earth's atmosphere scatters sunlight.
Okay.
So picture this. Earth is right between the sun and moon, casting a shadow. But the shadow isn't perfectly black. Some sunlight still gets through, but it has to pass through Earth's atmosphere first.
Well, okay, through the edge of the Earth, kind of.
Exactly. And our atmosphere acts like a filter. Imagine the moon being lit up by all the sunrises and sunsets happening on Earth at that exact moment.
Sunrises and sunsets. Okay, I think I see where this is going. Lots of reds and oranges there.
Precisely. Milligan points out the key thing. Blue light scatters much more easily in our atmosphere than red light does.
Right, that's why our sky looks blue during the day.
That's the exact same reason. The shorter blue wavelengths get bounced around all over the place by air molecules, scattered away. But during a lunar eclipse, the sunlight that skims through the edge of our atmosphere, most of that blue light has already been scattered out.
So what's left?
What's left are the longer wavelengths, the reds and oranges. They aren't scattered as much. They bend or refract around the Earth through that atmospheric filter layer, and they continue on their journey through space to the moon.
Illuminating it
with that leftover reddish light. So our atmosphere is like this giant cosmic lens, bending and coloring the light that paints the moon.
Painting it with that bloody glow.
That's a term, yeah. It's really a beautiful display of atmospheric optics playing out on a huge scale. Our planet is actively involved in the show.
It's amazing to think our own air is responsible for that color.
Yeah.
But does the exact shade of red change? Like, could it be darker red one time, more orange another? Does stuff happening on Earth affect it?
Oh, absolutely. That's a great question. Yes, the intensity and the exact hue, they can vary quite a bit.
Yeah.
And it's directly tied to what's going on in Earth's atmosphere at that time.
How so?
Well, think about major volcanic eruptions, for instance, or big dust storms. If there's a lot of extra dust or aerosols kicked up into the atmosphere globally,
Right.
those particles can scatter even more light, including some red light. So the moon might look darker, maybe a duller copper, or even deep brown.
Interesting.
But if the atmosphere is particularly clear, fewer particles, then more red light gets through, and you can get a much brighter, more vibrant orange or brick red color.
So each blood moon is almost like a little atmospheric snapshot of Earth at that moment.
That's a nice way to put it. A unique fingerprint, yeah.
Okay, that's fascinating. So with that science making sense now, let's get practical. Where and when can you actually see this thing tonight?
Right.
For everyone wanting to catch the show. The AFP report, our source references, gives us the lowdown on who gets the best seats. And spoiler alert, it's not visible everywhere, so definitely listen up for your region. Okay, the absolute best views, where you'll see the whole total eclipse from start to finish. That's going to be across large parts of Asia. Think India, China, they're mentioned as being in prime position.
Good spots.
Also the eastern edge of Africa and Western Australia. They get the full show too.
Okay.
Now, if you're in Europe or most of the rest of Africa, you might still see something.
A partial view, maybe.
Exactly. A partial eclipse, probably as the moon is rising or setting. Still cool, but not the full deep red experience.
Better than nothing.
True. But unfortunately for listeners in North and South America, this one's happening while it's daytime for you. So you'll miss this particular eclipse. Sorry.
There'll be others, though. Always more eclipses.
Definitely. Now, for specifics, using India as the example from the source, they gave some precise times. In Indian Standard Time, IST, the first subtle phase, the penumbral eclipse, starts around 10:01 p.m. on September 7th. That's when it might just look a bit dimmer.
Okay, the very beginning.
Then the partial eclipse, where the main shadow starts to bite into the moon, follows that. But the main event, the total eclipse, when it goes fully red, that kicks off at 11:00 p.m. IST.
That's the key time.
That's the peak viewing window. Totality lasts until 12:22 a.m. IST on September 8th. Then it starts moving out of the shadow.
Got it. So a good hour and a bit of the full red moon.
Yep. So plan accordingly if you're in that part of the world.
And this brings up something really important for people planning to watch. Safety. Is it okay to just look at it?
Good question. What's the verdict?
The verdict is a huge yes. Absolutely safe. This is the wonderful thing about lunar eclipses, unlike solar ones.
Right. Solar eclipses need those special glasses, or you risk eye damage, serious damage.
Exactly. But with a lunar eclipse, you can stare at it all night long with just your naked eyes. No filters, no special glasses, no telescopes needed.
Just step outside, look up.
Just step outside, find a spot with a clear view of the sky, maybe grab a chair, a blanket, and enjoy. It's totally democratic astronomy. No expensive gear required, which is, frankly, a relief.
Yeah. One less thing to worry about finding. Okay, so let's quickly recap the key things for everyone listening. Tonight's blood moon is a total lunar eclipse. That's sun, earth, moon lined up, earth's shadow covering the moon.
Check.
That amazing red color. It's not mysterious. It's sunlight filtered and bent through Earth's own atmosphere, scattering away the blue, letting the red pass through.
Our atmosphere doing the work.
We saw how it spooked and fascinated ancient cultures and how science now explains it beautifully. And crucially, if you're in Asia, Eastern Africa, Western Australia, parts of Europe, it's totally safe to watch. No special gear needed.
Just your eyes and a clear sky.
Yeah.
And stepping back for a second, just think about how this single event bridges time. It connects us directly to those ancient people looking up, seeing maybe omens or gods in that red moon, and it connects us to modern science, to astrophysics that can explain the light's journey in incredible detail.
Yeah.
It kind of shows that even knowing how it works doesn't diminish the spectacle. If anything, it adds another layer of wonder.
Right.
It's a reminder that the universe puts on these amazing shows, blending history, culture, and physics.
Beautifully put.
Yeah.
So final thought for you listening. As you look up tonight, or even if you just picture it because you're not in the viewing zone, think about that light.
Yeah.
Seriously, think about that journey. Sunlight travels millions of miles.
Mhm.
Then it hits our atmosphere, the very air around us. It gets filtered, bent, colored red, and then travels another 250,000 miles to paint them in.
Incredible journey.
What does that tell you about our little planet's role? Our atmosphere's influence reaching out across space. How does seeing that connection, that fragile layer of air creating such a cosmic spectacle, make you feel about our place in it all? Something to ponder maybe, long after the moon goes back to silver?